we're going to be doing PHP type juggling. Does everyone know how PHP type juggling works, or would you guys like me to go over it quickly?
I personally am a beginner to all of cybersecurity,
Mm-hmm.
but if I have a question, I'll ask it as I'm watching it or whatnot. So I mean, if nobody else needs it, I'm okay with just moving through.
Well, I
Don't have
think
a
I
clue what
think
it is.
yeah, I think we should totally see what we should have done. It's not a really
Okay,
easy
yeah, sure.
type
We
to
sure we go over it.
support.
So if you look at my stream right now in PHP, there's two kinds of comparisons. So a comparison is just how you're going to set a value equal to another, right? So basically an equal sign, but in PHP there's two different kinds of comparisons. We have a strict comparison, which is a triple equal sign, and as this chart set shows that a strict comparison is going to check the exact value, right? So true is true, false is false, one is one, etc. And that's how a strict comparison with the triple equal sign works in PHP. But PHP also has a loose comparison, a double equal sign. And for and that's called a loose comparison. And with a loose comparison, you get all kinds of funky things equal to each other. Like for example, we could see true is equal to 1, which is, like MySQL uses something like that. But we also see some other weird ones like the quote PHP is equal to true. And so with this arises a vulnerability called type juggling, which essentially is where we're going to take two values and set them true to each other when developers were planning on only setting it true if the values matched exactly. So this often occurs in like password reset type of vulnerabilities. Does anyone have any questions so far just about what a loose versus strict comparison is?
I'm good.
Okay, cool. So I just made a quick example. So so this is a very simple PHP script, right? We have var1 equals 0 and var2 equals 0e123. So I'm comparing them, and if they are true, we echo true, and if they equal each other, we echo true, and if they don't, we're going to echo false. So if I run it, we see it's true, which doesn't really make a lot of sense because these are two different values, right? And the reason why they're true is because this is going to be interpreted as scientific notation. So if you're unfamiliar with scientific notation, it's going to be 0 to the power of 1, 2, 3, which is always going to be equal to 0 because 0 to the power of anything is 0. And that's where the main vulnerability of PHP type juggling comes in. Is we're going to try, if we have input, we can try and make a value equal to 0 and make another value equal to 0, 1, 2, 3, which is often going to be a hash. So if we change this to like a triple equal sign, it'll echo us false because now it's a strict comparison. And that's the main difference. So PHP loose comparison, we're comparing 0 to, what are we comparing it to? To a quoted 0 basically, right? Because it's not exactly equal. But here it's not going to equal the same because that is a strict comparison, and that's the main difference between loose and false. So we're going to want a 0e value because that's the easiest way to interpret it for PHP type juggling. I linked this before, but this article really goes in depth on how exactly it works and why. And I'll show you later why it's bad. But there's another thing you're going to have to know with PHP, and this is another example. It's the exact same, but now we're comparing a string to an integer. And so with a loose comparison, so only two equal sign, and we're comparing 0 to 0. So obviously an integer can equal a string, but if we run it, this goes, we see true. And so the reason why this works is because in PHP, when you use a loose comparison and you're comparing an integer to a string, it'll actually convert this string to an integer. So in the background, it's going to do, I don't really know how PHP calls it, but it's going to basically do int of var2. Maybe it does it. It'll do that. And so when you convert this to an integer, what it's going to do is it's going to look for any numerical values in the front. So if 1, 2, 3 was here, then var2 would end up equaling 1, 2, 3 instead. It would equal basically 1, 2, 3. But if we don't have any values in the front, if we don't have any numerical values, if we don't have any numbers in the front, it's just going to assume 0 is in the front. So if I was to do 1, 0, this is going to return false because it's going to say var2 is equal to 1. So we get false. But again, when we delete it, when we delete it, it won't see anything there, so it'll just change the value to 0. Does that make sense to everyone of how PHP is interpreting an integer when we compare it to a string using a loose comparison? Because if we change this to a sorry, you can ask your question if you'd like, anyone. But if we change this to a strict comparison, it won't change 0 to an integer. It'll keep it as a string, and obviously this is going to return false. Does that make sense?
Yeah, I was just gonna say it makes sense. Thank you.
Okay. Yeah, and so that's where the vulnerability arises in PHP. This one, not as much, because normally it's going to be hard to get a string. So this is a vulnerability, but it's not as common. This is going to be more common when we have control of a variable we can set equal to 0, and then we're going to be able to set a hash value, typically an MD5 or possibly a SHA-1. MD5 is normally easier to exploit, to a 0E123. So if we go to payload all the things, you can see a really good example of this. So this has this also has a lot of good resources, but we'll ignore all this. But if we go here, we see these. It's called a magic string and a magic hash. The MD5 value of these is equal to a 0E. So in a loose comparison, this will be changed to 0. So imagine that we have an MD5 hash, and we'll just do this, right? So say in the database, this is what we want. Say in the database, this is the value being stored, 0E462, right? And we have a loose comparison. If we send this, it'll return true. So the server will think we're sending the correct value when we're actually not. So if this say it did I don't remember the exact syntax for PHP, but just like MD5 of var1, and we go here, and I took this one, but this one will also return true. So if we did like this will also return true, even though it's a completely different number, because both of them will be compared to as 0. And that's where the vulnerability rises with a loose comparison. But if we change it to a triple equal sign, the vulnerability won't be there anymore. So it's a really easy vulnerability to migrate from, but if developers don't know that the double equal sign is the vulnerability and they just leave it as is, that's where we can get authentication bypass. So does that make sense to everyone? People who joined late, does that make sense? Do you need me to go over everything?
No, that's good.
Okay, so we're going to be doing some practice ones. This is it's called Trouble 1 Type Juggling. And you just have to have Docker installed. So just run it with Docker, as it says, and then you can access it locally. So I already have it up and running, and obviously with type juggling you're going to need it through code review. It's going to be pretty much impossible to do it without code review. So for these challenges, we have the code. Challenges. Okay. Now it's just code. So I'm going to open up the code and we'll start reviewing. Get rid of these. Don't save. Okay. So we'll start with the first challenge. And the first challenge, are you going to syntax highlight for me? There it goes. So the first challenge is pretty straightforward. It's one of the vulnerabilities we talked about. So if we look at the website, we only have to input the secret key, and it's only allowing numbers. So here we see that key is equal to the post value of key. So what that means is it's going to send the key value in a post request. So whatever we type here basically is going to be sent as key. So we have control over the key variable. And then it's comparing key to the MD5 value of FGA blah 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 blah. So earlier when we talked about this one, when we compare a string to an integer, and if nothing is in front of the integer, it'll be set to 0. So for this one, we can look at the MD5 value of this, but I'm pretty sure it starts with a letter, so this will be set to 0. So if we set key to 0, it'll say 0 equals the integer value of 0, and it will return us a success. So if I just do 0 here and I hit submit, and we get success. Does that make sense why we got returned to success?
So MD5 of that FGA, whatever the keyword is, so that would start from 0E as well, right?
So here, we'll just look it up. So there's two possible ways this will do it. So it's either going to be a 0E value, or it's going to be a string. So we'll look it up and we'll see. If this loads. Alright, so we generate this value that they generate, FGASG, and it starts with a C. So it's comparing a string, because this is a string, right? It's not an integer because it has letters. So it's comparing a string to an integer. And like we saw earlier when we ran this, when we compare a string to an integer using a double equal sign, so loose comparison, only 2 equal sign, not 3, it returns true. So if we run example1.php, it returns true. But if we change it to a strict comparison, so a triple equal sign, it won't return true. So if I just change this to a triple equal sign, it's not going to return true. Oops.
So just to be clear, if we do 0 double equals to any string, it evaluates to true? Because
No.
that string starts from C, right? How does that convert into 0?
It will only return true. It will return true. Here, I'll show it again. User da. It's very confusing, but how it works in PHP is if when we compare the variables, so it won't permanently change this. It will only do it right here. So even if I did like an echo var2 here, it will still show 0. So only in this comparison string, in the background, what it's doing is it's taking this 0 value, right? And it's converting 0 sorry, the recording's really slowing down my machine, is converting 0 to an integer, right? So it's basically doing int 0, which doesn't work because 0 is not an integer. So how PHP reads it is it's going to look for numbers in front, right? So if we were changing, say it was like 1, 0, it would go, okay, 1, and then this is all letters. So we're getting rid of that, and we're changing it to 1. But if there's nothing in front, like how we have it here and for the C value, it will go, oh, no, there's no numbers here, so we're just going to change this whole thing to a 0, right? So if we had 1, 0, it would change it to 1. If we had 1, 2, 0, it would change it to 12. If we had 1, 2, 0, 1, it would still change it to 12. So once it hits the first non-digit, it's just going to kill the rest. Does that make sense?
Yeah.
So that's how PHP does it in loose comparisons only. If this was strict, we get false, right? That only happens with loose comparisons, so double equal sign. So double equal sign, this will return true. But if we change it to a strict, it's going to return false. And so that is how for challenge 1 we exploit it, because the MD5 value is equal to C whatever. Doesn't even matter. We don't even care, right? It sees C and it'll make the whole thing a 0 if we make key a integer. Does that make sense?
Yep.
Okay. So that's how you do challenge 1. Now we'll move on to challenge 2. Okay, so magic key is equal to 0. That's the first thing we see. And we see that magic key is going to be loosely compared to the key value. And then we see key value equals the request of password. So a request is going to be either a get or a post method, as it says here, or I guess a cookie as well. I think in PHP it defaults to a get method. So so what we need to do here is we see magic key is equal to 0, and we see request is password. So if we go back to our type juggling and we put 0 here, because that would be your first thought, you hit submit, we see it says failed, and we see up in our URL it does a question mark password, so a get request equal to a value. So that automatically looks like a MD5 hash, right? So if I just inspect element here, I think this is where it calls it. I haven't checked this actually. Where is it calling it? So it does the on submit equals encrypt form, and does it tell us exactly how it's encrypting? It's not. But if we go here and I just did a 0 and we do an MD5 hash generator and we generate it, we'll see that, wow, this is really running slow. Let me try closing some stuff down. Okay, are you going to work a little better now? Generate. No? Okay, that's going.
Yeah, I was just gonna say we can try to use like a command line utility.
Yeah.
Run define.
Yeah. Well, this, if I wasn't running a million things right now, so this is MD5 hashing essentially, right? So 0, this is the MD5 hash of 0. So since this is a loose comparison, we can do the second vulnerability I talked about earlier. example.php user.dir. We can do the second vulnerability I talked about, where we compare 0 to a 0e value. And since this will compare it as exponential notation, even if this is not a string, it'll compare this as exponential notation, so 0 to the power of whatever this is, and that will still return us a 0 value. So earlier when I showed you, when we looked at type juggling, we see there's already some pre-built ones for us, so we just need to take one of these values that when MD5 hashed will return a 0e value. So if I take any one of these, we'll do the first one, and we put it in and hit submit, we get success. And so if we do another one, say, and do a different value even, we also get success. And so we can even see in the challenge, it's hard-coded that the value is 0. So this is clearly a vulnerability, right? Because if, say, you just stored password hashes as MD5 sums, and some user's password ended up getting stored as a 0e value, we could bypass authentication that way. Anyone have any questions about the second challenge? All right, cool. So we'll move on to the third challenge then. And here we see it's going to be essentially the same as the second challenge. So we see magic key equals 0, which is later used in a loose comparison to the key value. And here we see key equals the request, so the get method of name3 with a period, which in PHP is a concatenation. So it'll just combine the two strings. So if I did name3 equals A and password 3 equals B, equals B, then key will equal AB. And that's what a concatenation is. Like in Python, it's a plus symbol. I think in most languages it's actually a plus symbol, but in PHP it is a period. So we see keys equal to the MD5 sum of name3 and password 3, and if key equals magic key, then we get a success. So this one, all we have to do is we take the previous strings we used and we just cut them in half, right? Since it's just going to concatenate them, all we need to do is just take half of it, put it in as name, and take the second half and put it in as password. And we get a success, and then this one actually prints us out our MD5 hash. And so since it's a concatenation, we can do anything, right? We can copy all of this and put just 2 as the name and put all that as the password. And it will still return the same value because it's just a concatenation, right? No matter where we break the point, it's just going to put it all together in this one string. And again, any of these values up to here will work because we're looking for a MD5 hash that turns into a 0e value. And these aren't the only values that return to a 0e. These are just ones that are stored. There's obviously a lot out there that will turn into a 0e value for MD5. Okay, anyone have...
If it's
Yep.
Yeah, it's a quick question. If instead of 0e we have something that's 0d, then you have some bogus string at the end, so that would evaluate to 0 as well, right?
Not always. We're looking for 0e because we're looking for exponential notation. So it'll depend on how it calls it. Do we have a 0d here? Good. We'll try this one. This one doesn't return a 0e, it's just a 0.6. Oh, that won't even work. But we're looking for something that will call it as exponential notation for these challenges. Because we're going to be comparing the values as strings, we want 0e, or I'm sorry, as integer 0e to try and change it to exponential notation. So it'll change it to exponential notation, and then we will, and then obviously 0 to the power of whatever will be 0.
So I think you showed an example where you have like 1, which is like the actual number, and then you have zero. So that evaluates to 1, right? So doesn't that work for 0D? Just because everything that's
This one?
so it only takes the first number.
Yes, it'll depend on how it's called, right? It's going to just depend on how the database exactly calls it. Normally, the 0E is the best way to do it. But in terms of like, so you're saying like if we just did like for challenge 3, if whatever this, if we got key to equal like 0 whatever, that's what you're
Yeah,
asking?
0 whatever. Yes, yes.
So it'll just depend on how the data is sent. So usually you want to do 0E because that's a guarantee bypass. There's no, you can't always guarantee it will compare it as as a integer, right? We don't want it to be like this, because then it's not going to work. Then it won't work properly. So a 0E value is your best bet to always get it to work. Okay then. Does that make sense to everyone? Alright, so we'll do challenge 4 then. Alright, so challenge 4 is going to get a little more difficult. Here we see we have some conditions to be met. So we see must contain at least one number, one uppercase, one lowercase, and at least 8 or more characters. So if we look at the code for challenge 4, we see it's going to do pretty much the same thing as challenge 3, where we have a magic key variable that's set to 0, and we have a key variable that is going to be equal to name4 concatenated to password4. And so what we're going to want to do is we're going to want to find a 0E value that is we're going to want to find a value that concatenates name4 and password4 and makes it into a 0E value in MD5 hashed, but we have some conditions that have to be met. So we need one number, one uppercase, and at least 8 or more characters. So if we look at payload all the things, we don't really have anything that will meet that criteria. But if we look here, this is how I did at least. Inspect element. If we look here, so here we see the regex filtering for the password field. So we see where it requires stuff. But if we look at the name field, it's not going to require any of that regex garbage. If you're unfamiliar, regex is just a way of requiring things. So the pattern equals az 8 comma, that's how it's going to be checking for an uppercase, a lowercase, and 8 or more characters. But for name, we're allowed to put whatever we want into name. So to test that, I'll just do like 1 2 3 for name, which does not match, and then I'll just write a test payload that does match for password. So you can see up here my request is just 1 2 3 and then just test, which matches the requirements, but obviously it's not going to return the correct value, so fail. And then if I try like just 1 and 1 here, we get an error. We try to submit and we don't get it. So we see only the password field requires all of this junk. So what we do here is we're going to now write a script that will tell us how exactly we can. We're going to write a script that's going to compare values and see if we can get a value returned. Okay, sorry, I'm not explaining this right. So what we're going to do is I'm going to write a script and I'm going to hard code the password value. So like here we know test 1 2 3 4 5 6 is valid. I'm just going to do pass 1 2 3 4 because this is valid. It's got an uppercase, lowercase, numbers, and is 8 characters. Do we even need digits? Yeah, one number. So I'm going to do this. I'm going to hard code pass equals 4. And then I'm going to write a script that iterates through everything. A1, right, sends values, concatenates them, and then produces an MD5 hash of that. So, for example, I'll do like, so I'll hard code this value, and then I'll go through the name variable and do like name equals A. Then I'll recreate how PHP is doing this. So I'll do, it's a little different for Python. So I'll just do like, for example, it's just going to be MD5 of name and password, right? And password. And then and I'll just do like, if this is a 0E value, then give me the name variable. And then that way I can find out if that way I can find a valid name variable while keeping password to set to the requirements instead of doing a really long script to like, or a really complicated way of setting different things. I can just hard code the password value and then brute force a name variable. Does that make sense to everyone, what we're going to be doing in this script?
Yep. Shouldn't you try for 2 characters in name so that you get 0 and E when those hashes are created?
So what we're going to do is we're going to create a script that like goes like A, B, C, D, and then if none of those returns, it'll go like A, B, A, C, and then if none of those
Okay,
returns,
got
it
it.
will go A, and stuff like that. But MD5 hashes will work in like, it'll just go with like we saw with the zero value when we just did 0 earlier. MD5 hashes will always make the length the same, so any value can return to a 0E value. I mean, theoretically, any value can return to a 0E value. So it can, it doesn't really matter what we start at. We just need a valid name variable. All right, so for this script, let's first get my syntax highlighting to Python. So we need hashlib to create the hash, string itertools to iterate through everything, and I'll use sysarguments. So now we're going to create a function called, we'll call it gen, and it'll take 2 arguments, username and prefix length. So the username is going to be the name thing that we wanted to brute force, right? We just wanted to do like name equals. And later on, we're going to hard code, or we'll pass in the password, I guess, as a, we'll pass in the password as a user argument. So if we want to do something other than pass 1 2 3 4, we can, or if, say like requirements change and now they require 10 characters, we can do like pass 1 2 3 4 5 6, whatever. So this is going to be the looping script .imap. So we're going to basically create a for loop, and forward in itertools.imap, we're going to loop through everything, and then we're going to do a .join. So basically we're going to start in a second. We're going to be defining the ASCII lowercase variables. So basically what we're saying is if A through Z doesn't return anything, then join the A and do the B. And that's basically what this is saying here. And I don't know how to spell. And then we're going to do so now we're doing the product of string dot lowercase. So we're just going to be doing lowercase values. So just A to Z, instead of like including uppercase and 1, 2, 3s, we'll just do lowercase values. And then we're going to do repeat equals prefix length. So, and then we're going to repeat it. We're going to do how many times we're going to basically say prefix length is going to be equal to how long we want it. So if I set prefix length equal to 3, it'll do AAA and go through that. If I want prefix length equal to 5, it'll do AAA, and then it'll do B, and then C, and then D, and it'll brute force it that way. Does everyone get how this for loop works? All right.
Yep.
Cool. So now we're going to actually create the hash, right? So basically, we're just going to, so this is just going to always be our loop. We won't ever really have to change this. You can keep this always the same. But now we're going to have to recreate the hash on how they do it. So when I tested this, it was a little weird. And in the back end, it runs it a little different than how they say. So actually what we have to do is we have to call in our %s variable. Oh no, wait, no, sorry. I'm thinking of this backwards. So first we're going to have to call in word, right? So first thing we want to do is we're going to word, right? That's going to be our AAA whatever, B, C, whatever variable. So we're going to brute force through that. And so that's what we want brute forced. And then we're going to want to do that to plus PW. So PW is going to be the password we set, right? So word is our brute force because we're doing a for loop on the word for. And PW is going to be something we hard code. So later on we'll do like PW equals pass 1, 2, 3, 4, but we'll pass as a command line argument so we can set it to exactly what we want. And then we have to do a hex digest on this. Hex digest. Just because that is how you call it for Python. Alright, and now we're going to do a match. So what we're doing is we're checking to see if any of the return values of hash are going to equal to this regex string. I think that's right. 0 plus. Okay, yeah, I think this is right. So basically what we're saying is re.match, so just regex value match 0, because we want it to start with a 0, and then plus these brackets, we can do either of these values inside these brackets, basically an or, so we want E or E, and then we're saying any value, and then we don't really care what comes after that, right? Because we could do E, whatever. We can do whatever we want, right? Like do any funky characters technically, even though that's not how MD5s work. Doesn't matter. All we care about is 0E. So if we get a value that returns that, we can print okay, hit something. We can print found, or this is going to be Python, I don't need quotes. Print found valid username for type juggling %s, and we're going to do the %s is going, or % word because we're going to want to do whatever word equals before we MD5 it, and then we're going to do the same thing. Print. We'll do print hash is s, and then we'll print the hash variable. So that way we get told what value we need to pass in for the word. Does that make sense? What we're doing? All we're doing is just a really basic regex max. So we're just looking regex match. So we're just looking for 0e or 0e on the hash value. And then if we find it, we're saying tell us what it is, so we can input it. Does that make sense?
Yeah, this is off topic, but
Yep.
why do you prefer Python over like bash scripting?
OSWE taught it in Python, so I have all my pre-built scripts in Python, to be completely
Okay.
honest. But you could do this in any language you want, right? You just gotta, it's the same logic. You do this in any language you want.
Okay.
So
I've heard some people say that Python
Mhm.
scripts are better than using like bash scripting. So I'm just wondering if that's true.
I think they offer more functionality. I'm not a huge programmer, so I can't speak to that. I think there's some people in here who know a lot more about programming than me. So I can't personally speak to that, but I personally just know Python the best. So I'll do everything through Python basically.
Cool.
Okay, so now we're just going to be setting up our main function. So we're just going to be checking. We're just going to be making sure. So we're going to be setting two system arguments. Print need arguments. We're going to be setting two system arguments, and we have to set this to 3 because in Python, when you run the script from terminal, it's going to be like Python script.py, and then first argument, second argument. But for the script, it's used as 3 arguments because we have script.py, which technically counts as an argument, and then we have 2 other ones. So technically, we have a total of 3. And then we'll exit if that fails. Okay, so now we need to set username, which is up here. Nope, which is up here, which is what we're brute forcing. And we're going to set it equal to sys.argv1. And then we're going to do prefix length, which is equal to sys.argv2. And then we're just going to run our script with the username and prefix length variables. So now we can pass in any prefix length we want. And then I'll just call it quickly, and then we can talk about the script a little more. Okay, so we're just going to be calling, this is our main folder. We will call it challenge4.py. So we need the username. Wait, no, I did this wrong. I don't want username, I want password. So we want password, right? I don't know what that means. I think we're fine. Because we call password here, right? I don't know why I did username. We want password here because we're going to be calling in any password we want. So we're going to do like pass1234, and we'll call that in, and that'll be the second part because we're reversing how they did it, which is password here, and password's the one that has all the funky arguments. So we'll call it there. Why is there issues? I don't know what that means. And then we want prefix length. So we're going to tell it if like prefix length of 3, we do AAA. If we want prefix length of 5, we'll do 5. And that's pretty much all. And then I don't know why I called it that. BW. So does anyone have any questions about the script? Okay. So when we have a complex password like this, you see my test here. You can't always guarantee that like a prefix length of 1. You can't always guarantee like a prefix length of 1 or 2. Something that's so short will return something. But you also don't want to go crazy and do like a huge number and have it run forever. So what I personally do is for this, I just do a little, yeah, thanks Bash History. I just do a little bash script. So basically what I'm doing is, okay, I have it saved. So basically what I'm doing is I'm setting the I variable to between 0 and 15. I guess it should technically be 1 because 0 won't do anything. And then I'm passing it in through, then I'm running my actual script, right? So this is what we'll concentrate on. So I'm running the script with the arguments of pass 1, 2, 3, and then I'm setting the I variable, and I'll tell myself I'm doing that one just to give myself an update. So basically that way I can iterate through 0, 1, 2, 3, 4, 5 all at once instead of having to set up manually, because I don't know if like 5 will return a result or 8 will return a result or if 10 will return a result. So that way when I run this, it'll iterate through it for myself. So as I can see, I already did 0, 1, and 2. They didn't return results. So now I can just run this, and actually for this script I didn't even get a hit until 6. I was planning on letting this run because this will take a minute. We're at 4 and they'll get progressively longer. But if my machine starts to slow down again, I will stop it. So I got a hit when I ran this last night at 6 is when I got my first hit with the password of 1234, and it found, hang on, let me grab it. It found this value. It found this value to be a valid username. So this way, 2, 3, 4, this value essentially, let's see if we can get the website to work. Not looking good. Maybe I'll just do it through Python. Essentially this value is going to return us a 0e something something hash. So if I take this for challenge 4, yeah, this, I don't know what's wrong. If I take this for challenge 4 and I put that in, and then for password I do capital P ASS 1234, hit enter. You see up here, that's what I sent. And there we go. I guess this will hash it for us, so we don't need to do anything. And we see we finally get a 0e value. So that's what this script does. It's going to iterate through, and we're just checking to see if we can get a 0e value.
Sorry, why do we need to run the script 15 times or like 6 times?
Because of prefix length, right? So for iter tools, it requires a like repeat for prefix length. So when we do a prefix length of I'll do this, print word. So if I go here, nope, to terminal, and I do python challenge4.py 1, you see we do 1, right? We have a prefix length of 1. If we do 2, we now have a prefix length of 2. If we do 3, prefix length of now 3 total.
Okay, that makes sense. Yeah.
Oh,
Cool.
the next one hit it. Stop. The only bad part about this bash script is you're going to have to hit Control C a bunch of times to exit all of them. But yeah, so that's why I personally just sent it through this, because I just set it up, right? because once you reach 5, it takes a really long time. Once you reach 5, it's going to take a really long time. So I kind of just set it up and I just let it run. And then when I came back, it found a hit at like, I think it was pretty late in 6. I think I almost hit 7, or I guess not. I guess it was only B, right? But we have a lot of brute forcing to do at those. Once we hit like 5 and 6, and my computer isn't super. I'm not running anything special, so that's what I did. I just set up, let it run, and then it ran in the background. So that way you don't have to like check in every 5 minutes, right? All right. So if anyone else have questions on challenge 4, I know that was a really big jump from 3. I know 3 was pretty straightforward, and then 4 we had to write this whole script, but the script is pretty simple. Here we're just iterating through an alphabet because a string lowercase, right? Say we had to do digits, we just do like string dot digits, I believe it is, or string dot uppercase if it wants uppercase. But we just do lowercase because easy. And then we take whatever the value of word is. So that's going to be these values, right? These values are word. And we reverse the hashing as they do it, because the hash here is name4 concatenated to password4. So we do name4, which is word, concatenated to password, which has the weird filtering, which we set to match the weird filtering, the uppercase 8 letters and a lowercase and digit, hash it, and we see if it is going to equal a 0 e value, and if it does equal a 0 e value, it will return us with a word. It will return us the word, I mean. So does that make sense to everyone?
Yep.
Okay, cool. So we'll move on to I think update email's easier. All right. So now we're going to now we're really getting into it. I think they actually give me, is this update email? Okay. So now we have a bit of a harder challenge. So looking at this code, we see we have three variables in an if parameter. So what this means is if we go here and we have our if parameter, we have to have these values set. So we have to have E, ID, and M set to enter that code branch. So we have to have E set to some value, ID set to one value, and M set, what am I doing? And M set to some value, like this. Right? So that's what happens for this get request, right? Because the request, wherever we are, close that for now. Because it says if these are set, then we can enter this code branch. Otherwise, we'll skip the code branch and overall, and nothing will happen. So we have to have these 3 values set as a request, which is a post, a get, or a cookie. So if these 3 values are set, we're going to have ID equal to the integer value of ID. So we control ID, right? We can set ID to whatever we want, but it'll be an integer. So say we'll set it to 1. E will be whatever we want, and same with M. So we can set E and M to any values we want. So we can set it to whatever, and we can set M to whatever. And then E has to have an @ symbol, is what this is saying. So we can actually set it to whatever. We have to have an @ symbol to enter that code branch. So probably like an email, right? So like new email at test.com. And then we need the date variable not equal to null. So we have to set it, so date has to not equal null, which we don't see anywhere in here. And if date's not null, then we will create the substring 0 to 10. So it'll take the first 10 digits of this MD5 hash of E, date, and ID. And then it'll take that, put it to the code variable, and it'll compare it to M. So that was a lot. Anyone have questions? Because that was a lot right there. Okay, so what we know here is that we have a loose comparison. And with the loose comparison, we can update an email address. So what we need is we need to have E, date, and ID return a MD5 value of 0E, and we control the M variable through a get request. So if we go back here, we can just do M equals 0. So then that way, here in the actual code, we'll have code equals 0. And now if we can find a way to set E, date, and ID when they're MD5 hashed to a 0E value, we can bypass authentication altogether. So what do we have? We have E, which is 100% under our control. We can set E to anything we want, but it has to have an @ symbol. So we can set it to anything we want, and it has to have an @ symbol. Date has to be set, and it can't equal to null. And ID has to be an intval variable. So looking at the top of the code, we see an include. We also see an add slashes equals trim. So basically that means we can't have spaces, which we wouldn't really want to do anyways, because that's going to be annoying. So we can't do spaces. But we see an include at the top here. And it says update child values.php, which is this code right here. So looking at this code, we actually find our date variable set here. So we see date equals 2017-05-25. So now we have our date variable. So if we go here, we know this is what we need to do. E, we control. That's our value. We can set E to anything we want as long as it has an @ symbol. Date is a hard-coded value, which, sure, okay. In like scenarios, it's going to be like creation date in a database. So like when the user created it or something. So date's a hard-coded variable, so, and we're concatenating these. So right now it's going to pretty much look like this. ID, we're going to set ID to 1, since ID is also going to likely be a database variable. So we set it to 1, since we want, say, the first user. But it has to be an integer. I guess we could set it to other values, but I just did 1, because we know if this actually queried the database, 1 would be the most likely to be in there. So we @ control say. So now, and this will all be MD5'd. And then we're going to take this value, which is code, and we're going to set it to a loose comparison of M, which we also have complete control over. So then we're going to do code with a loose comparison equals M, and up here we have complete control over M. So we can set M to 0, which pretty much enables us to do a type juggling vulnerability. We have 2 hard-coded variables, and we have 1 that we have complete control over. So using this, we can go back to our brute forcing script. I probably shouldn't have closed it. Going to take this. We're going to leave like I said, these are pretty reusable. I'm going to just save it to type juggle email.py. So we can leave this loop right here the same. We don't have to update this. What we need to update is, we'll start with the easy part. We don't need to hard code a password anymore. So we don't need any of this. All we need is a prefix length, right? We don't need the password. So we'll change that. That's easy. Now we need, the only part we need to update now is this hash variable to set it equal to this. So what we do is we take this, and we could set it up here, but I'll just do it in here. We're going to set this, we'll do it in different parts. 1. So now we have our %word, which we're iterating through, our date, and our ID. And the last thing we need to do is we need to set this equal to the syntax they want. So it's going to be an email address, so we'll just do like @test.com. And that's all we have to do to update this script. Does anyone have questions? I guess technically what we'll do here, just so you guys can see, I forgot, is we're going to take the first 10 characters, right? So like in case, so you just do the with 10. So if this was like, if this was like 5, 10, then we could do that as well, right? If this, then we just do 5, 10. But just to show, we just do 0, 10, but that won't matter because all we care about is the first 2 numbers. Sorry, what was your question?
So the date is already like 10 characters, right?
Yes, but this is the MD5 value, right? So it's going to be the MD5 value of this is going to be set to the 10 characters. Right? It's not going
Okay,
to
got it.
take
Yeah.
the first 10 characters until after the MD5 hash is executed.
Okay.
Which MD5 hashes are always going to be the same length of some value. I'm completely forgetting. So we set our filtering up to bypass the @ symbol, which is required for the E variable, which we control, so we're going to be brute forcing that. The date is hard coded in the include up there. And the ID, we're just going to use an ID of 1. And then, so this looks good. Save this. Python email.py, and we'll just do like 3. That's right, I did not. We don't need this anymore. Forgot to update all the other parts. Okay. And now we see we found a valid type juggle right away. This one was a lot easier, just ZFW for test.com. So we're going to need, so I mean, to make it a little easier on ourselves, we'll do print like E value is %s at test.com, just so that way for our reference. %word. So now we know E value is this. So with this, we can go back to our URL, and all we have to do is change our E value to this, and we'll be able to update our email. And email address has been updated to zfw at test.com. Does anyone have questions? I know like this code branch is a little confusing, but all we do is we see we have control of the M variable, which is what we want to set to 0 because we're doing a loose comparison on the code variable. The code variable is going to be set to the first 10 characters of the MD5 hash of E, which we have complete control over, except it requires an @ symbol, date, which is hard-coded here, and ID, which we have pretty much complete control over as the intval variable of the request, so we just set to 1 for convenience. And that is how we were able to execute this and get a type juggling vulnerability to update the email address. Does that make sense?
Yep.
All right, cool. So we only have one left. And sessions. So here we're going to be following the same logic. I don't think they give us in anywhere here. I don't think so. So we'll have to look at it here. So we see it requires to enter this code branch, we have to set a request of message. So we just got to do message equals, and then hmac is going to equal the MD5 sum, or just the MD5 value of secret, which is equal to the string secret random secure value concatenated to message. And then if hmac, the hard-coded hmac, equals the request of hmac, we get success. So this one they try and throw you off a little because they use hmac twice. We have a variable hmac and a request hmac. These are not the same. Hmac here is not equal to this, right? Pretend this hmac says anything else, or pretend this says something else. So we have to set a variable called hmac, and we have control over it, which is 0. So we do if hmac equals 0. So if the MD5 hash of this string concatenated to a message we have complete control over equals the request, so the get parameter of hmac, which we also control, then we get success. So we set hmac equal to 0 to basically enable the type juggling vulnerability, and then we are taking, then we have to find a value that when sent, when concatenated to secure random secret value, will return a 0e value. So to do this, we're going to go back to this, take this, do a new script, save this as session, and this is the nice part about this script is it's just reusable. We'll just get rid of this. It's not requiring any of this. And all we need is to take secure random secret value, and then we concatenate it with a plus in concatenate it with a plus for Python, since it's a period for concatenation in PHP, but in Python you use a plus. And then we'll just do, whatever works, %s, and then we'll throw in the loop of word, and that's all we have to do. We don't want this because that was just for our reference for the other one, and that's all we have to do to get this one. So then for this one, this one I had to use the bash loop again, right? The same as this. just because with it took a while. And hang on, let me pull up my cheat sheet. It took up to 7 to find one, and I found a few actually. So you know what? We'll go straight to 7. Doing 6, doing 7. All right, so we'll let that run for a minute, see if it can actually find something. And this returned a valid 1, and that's success. So we'll see if this can run and find one. I don't know how long it'll take. So all we have to do for these scripts is just update the hash, really. Or if they require some weird filtering, we'll have to set that as well. But all we have to do is update the hash to what it requires for their own hash. And then we can do an offline brute force. So we don't have to touch the server or anything to find a valid request. And then when we send it, we can send it with a single request and bypass authentication. So like the email one showed, sometimes like an update email might be like that, right? They might have really weird parameters in an update email, and then we can update the email to anything we want. So like maybe we do, instead of that, for example, if that was how you really updated emails, instead of doing test.com, we would do at gmail.com. And there's a good chance if we set prefix length equal to like 10, then whatever random number we get probably won't be registered to at gmail.com. And then we can just take the value, register that email, and then like ask for a password reset if we're not automatically logged in. And then we can reset the password and we would have access to that account.
I'm not sure how MD5 works, but you can add something to the end of plain text and you can control what's in the beginning of the ciphertext with MD5.
Sorry, I'm not sure I understand your question.
So, yeah, so we're adding a few, like let's say we are brute forcing the characters in the end, right? Because in the start we already have secure underscore random underscore secret underscore value.
Underscore
So,
random. Yeah.
so in the start of our plain text, we have secure underscore random underscore secret underscore value, right?
Yes.
Now we are brute forcing some characters after this,
Yes,
such that the whole MD5 hash starts from 0E.
that is correct.
Okay, so you can pretty much add something at the end and still control what comes out.
Yes,
Like,
yes, that is
okay,
correct. Because of how,
okay.
sorry, not to interrupt you, because of how,
Yeah, because of how MD5 works.
yes, because of how MD5 works, but also here, right? Because that's what they're doing. They're taking the secret random secure value and concatenating it
Hmm.
to the request value of message. So when we sent message equals this, it's taking secure random secret value and concatenating it with this value and then MD5ing it. So
Hmm. So isn't it like corresponding? So like, so doesn't it generate the hash character by character? So like S has some hash, E has some hash, and then C has some hash, and so on.
no, it's taking the entire string and hashing it
Oh, okay, got it.
because
Okay.
it's in the parentheses. So it'll take the entire thing and hash it, right? Like, for example, like you shouldn't, but say MD5 values were stored on, like, say, like if you were running your database and you were storing passwords as MD5 hashes, and then, like, say, like a user did his password as password 123, right? And on the database, you stored all your passwords as MD5. It would hash this entire password 123 as an MD5 value, right? So we take the whole value of password 123 and MD5 it. Not we don't do it one character at a time. You take the whole value and then you MD5 it, or however else you do. You SHA-1 it, whatever you want.
Okay. And MD5 of password 1234 would look vastly different from MD5 of password 123, right? I mean, even the starting characters would be different, right?
I'm not super familiar with how MD5 actually does their hashing, but they will be different. There's a good chance they'll be completely different. I can't tell you
Yeah.
off the top of my head what they'll look like,
Okay.
but they're not going to be similar. Password 123. Generate 482138 for password 123. And if we do 1234 BDC8
Yeah, got it.
9077. So
Nice.
that's, yeah, it's right. The hashing's supposed to be like secure in theory, right? So you can't guess like, oh well, if it's not password 123, if it's 123 different, they'll all be different values. Does anyone else have any questions?
Let's have one more thing. So, in the real world, we don't have access to the code, right? So how can we? So are we like doing different combinations of two different input fields we have and just trying a bunch of things, or?
So in the real world, you won't. I mean, it depends, right? You could be doing a source code review for a company, so they give you all their code. Do it in internal third-party applications. So applications on like GitHub or SourceForge are all open source. So you have access to the code repository, and majority of people use third-party applications. So maybe a third-party application is vulnerable to PHP Type Juggling, and it's implemented somewhere on a website. Then you can exploit it that way. So you do need the code for PHP Type Juggling, but there are ways outside of, say, just like a white box approach to get it, right? Normally third-party application be your easiest
I
way.
suppose,
Sorry.
I suppose you could chain it with something like LFI,
Exactly.
so that
Exactly.
you could drag down the code with LFI and then do this.
Exactly. That would also, LFI would be a great way. Uh, Anyone else have any other questions? All right, cool. So I'll be around for a bit if anyone wants to ask me anything.